minimum depth for a grounding rod, when used to ground a 55-gallon drum containing flammable liquids, is 10 feet. This depth is crucial for ensuring effective dissipation of static electricity which can accumulate during the transfer or handling of flammable liquids. Grounding provides a low impedance path for electrical charges to flow to the earth, minimizing the risk of sparks that could ignite flammable vapors. The purpose of grounding in this context is to equalize the electrical potential between the drum, the liquid it contains, and the surrounding earth. When flammable liquids flow, agitate, or are transferred, static electricity can be generated. If this static charge is not properly dissipated, it can build up to a level where a spark can occur. This spark can have sufficient energy to ignite the flammable vapors, leading to a fire or explosion. Therefore, a properly installed grounding rod serves as a critical safety measure. The grounding rod itself should be made of a conductive material, typically copper or copper-clad steel, to facilitate the efficient flow of electrical charges. The connection between the grounding rod and the drum must also be secure and made with appropriate grounding clamps and conductors. A conductor should be sized appropriately for the anticipated fault current, but in most cases for static grounding a smaller conductor is sufficient, such as No. 6 American wire gauge copper. It is also important to ensure that the grounding rod is installed in an area with good soil conductivity. Dry, sandy, or rocky soil can significantly reduce the effectiveness of the grounding system. If the soil is not naturally conductive, it may be necessary to treat it with a ground-enhancing compound to improve its conductivity. This can involve adding materials such as bentonite clay or other specialized grounding materials to the soil around the rod. The installation process typically involves driving the grounding rod into the earth using a ground rod driver or similar tool. The rod should be driven vertically to the required depth of 10 feet to ensure that it is in contact with a sufficient amount of soil. Once the rod is installed, it should be tested to verify its effectiveness. This can be done using a ground resistance meter, which measures the resistance between the grounding rod and the surrounding earth. A low resistance reading indicates a good ground connection. It is also important to periodically inspect the grounding system to ensure that it is in good condition. Check the grounding rod for corrosion or damage and ensure that the connections are tight and free from corrosion. Regular maintenance can help to prevent problems and ensure that the grounding system continues to provide effective protection. In addition to grounding the drum itself, it is also important to ground any other equipment that may come into contact with the flammable liquid, such as dispensing nozzles, pumps, and transfer hoses. This helps to create a complete grounding system that minimizes the risk of static electricity buildup throughout the entire process. Furthermore, it is important to follow all applicable regulations and standards related to the storage and handling of flammable liquids. These regulations may specify additional requirements for grounding and bonding, as well as other safety measures. It is recommended to consult with a qualified electrician or safety professional to ensure that the grounding system is properly designed and installed in accordance with all applicable codes and standards. Proper grounding is an essential safety measure for preventing fires and explosions when handling flammable liquids. By understanding the principles of grounding and following the proper installation procedures, it is possible to significantly reduce the risk of accidents and ensure a safe working environment. Remember, the 10-foot minimum depth is a critical factor in achieving effective grounding and protecting against the hazards of static electricity.